In this problem, we need to show that the points with the following coordinates form the vertices of a right-angled triangle. Let us begin. So here what we'll do, we'll consider a triangle with vertices A, B and C such that A, B and C corresponds to the following three coordinates respectively. Now what we'll do, we will try to represent each of the three vertices in terms of the position vector. So for that, we are going to consider a point O, which is going to be the origin. Then, with respect to the origin, position vector of the point of vertex A. Position vector of vertex A is going to be defined by OA vector. So to define OA vector, all you have to do is join point O and A with the help of a direct line segment going from O to A. Similarly, we can define the position vector of the vertex B. So that's going to be OB vector. And position vector of the vertex C is going to be OC vector. So now that we have defined the position vector of vertex A, B and C, so let's also try to express it in terms of the unit vector I cap, j cap and k cap. So the position vector of vertex A is going to be 3i cap minus 4j cap minus 4k cap. Position vector of vertex B, so that's going to be 2i cap minus j cap plus k cap. And position vector of vertex C, that's going to be I cap minus 3j cap minus 5k cap. So now that we have OA vector, OB vector and OC vector, using this we will be defining the vectors AB vector, BC vector and CA vector. Okay, so let's first compute AB vector. So now AB vector, that's going to be defined in terms of the position vector as OB vector minus OA vector. So let's use the value. So OB vector corresponds to 2i cap minus j cap plus k cap. And from here, we're going to subtract OA vector. So OA vector is going to be 3i cap minus 4j cap minus 4k cap. Now that's going to be equals to the 2i cap minus 3i cap, that's negative I cap. Negative j cap minus negative 4j cap, so that's going to be positive 3j cap. And we have k cap minus negative 4k cap, so that's going to be positive 5k cap. So we have obtained the vector AB. Now that we have the vector AB, let's also compute its magnitude. The magnitude of vector AB, that's going to be equals to, we'll have to take the square root. Underneath the square root, we take the sum of squares of the coefficient of I cap, j cap and k cap. We'll begin with the coefficient of I cap, so that's negative 1. Squared is added to the coefficient of j cap, so that's 3. Squared this value and added to square of the coefficient of k cap. So that's going to give us square root of 35. Okay, we're going to keep it aside for the time being. Next, we will be computing the vector BC. So we need BC vector. So BC vector is going to be OC vector minus OB vector. The OC vector, that's defined by I cap minus 3j cap minus 5k cap. And from here, we're going to subtract the vector OB. That means position vector of point B. So that's 2i cap minus j cap plus k cap. This is going to be equals to I cap minus 2i cap. So that's negative I cap. Negative 3j cap minus negative j cap. So that's negative 2j cap. Minus 5k cap minus k cap, so that's negative 6k cap. Now let's also compute its magnitude. Magnitude of side BC, that's going to be equals to, we'll take the square root. Underneath the square root, we have negative 1 squared added to negative 2 squared added to negative 6 squared. So 6 squared, that's 36. 2 squared, that's 4. And negative 1 squared, that's 1. So we have square root of 41. Right. And then we will come to the vector CA. So CA vector, that's going to be equals to, so we need OA vector minus OC vector. The OA vector will be 3i cap minus 4j cap minus 4k cap. And from here, we'll subtract OC vector. So that's I cap minus 3j cap minus 5k cap. That is going to be equals to 2i cap minus j cap plus k cap. Now let's compute the magnitude of vector CA. Magnitude of vector CA is going to be the square root of, so we have 4 plus 1 plus 1, so that will be square root of 6. Okay, so what we obtain? We obtain that the magnitude of side AB, that's square root of 35. BC came out to be square root of 41 and CA came out to be square root of 6. Now, here there's a perfect relationship that exists between the sides AB, BC and CA. So in triangle ABC, so if we consider the side BC, square it as, and this is going to be exactly the same as sum of the squares of the other two sides. That means we have AB squared plus AC squared. Now what does it tell us? This tells us that ABC is actually a right angled triangle. It's a right angled triangle. Now BC being the hypotenuse, so that means it's going to be right angled at angle A. So we have successfully proved the problem.